Hello, guys. W- uh, Welcome to our session 6, which is probably going to be our last session uh, for this course. We were in the last session, which was session 5. We were discussing distributed antenna system DAS designing using Ibwave. We have covered approximately one third or little more than one third of the whole chapter. Besides this, today we will cover RFDS for DAS, and we will look at a flowchart diagram of a workflow of RFDS itself, RFDS workflow itself, which is very important, and that workflow is true for both macro and DAS sites. Then we'll move to the DAS, the next chapter of RFDS for DAS, and then we'll see the R&D cycle. Hopefully we'll complete all this in this session's 6 today. One thing before we move on, today is our last session, and we have come across many discussions and many course material. We have so far published 2 quizzes. Results of these quizzes were discussed. We are still in process of receiving the attempts for those quizzes from some of you. The thing is, there will be more quizzes coming up. There will be at least 4 or 5 quizzes in total, means 2 or 3 more quizzes coming up. You guys will attempt that quiz, then maybe the session ends today or tomorrow, depending on how fast we go today. So in this program have been designed with 4 or 5 quizzes. You'll attempt those quizzes. No matter if this session ends today, it means this course is not finished. You will attempt those quizzes. Then there will be a grand quiz. So the guys who are willing for the certification will have to go through the grand quiz. The minimum cutoff mark for the grand quiz is 85%. The grand quiz is going to be around 1.5 hours to 2 hours in duration. That grand quiz, once anybody who has 85% in that grand quiz will be eligible for practical test, which will be conducted. So after you pass through the practical test, then you will have the certification. This whole certification exercise is free for the students which are attending right now. So if you guys are interested, keep attempting the quizzes, and you will receive the grand quiz. You can be in touch through the blog or through the email or through the Facebook page we have, or Facebook group we have. This is the one thing. Second thing, any of you guys who are interested in more progressing their career in the field of RF engineering and want to work with Module Solutions and Services MSS LLC with regards to preparation for the CV and the interview, and we forward your CV to our clients, then we can do that as well. We'll be discussing that on case-to-case basis based on visa requirements, based on the visa requirement or the work status you have. What we can sponsor the work status as well from Module Solutions and Services MSS LLC. And we can move on from there if we can work together in the future as well. So there are 2 different things, is certification, which is free for now. And the second thing is if you want to move on with the organization and how much value you see in the organization, and which is Module Solutions and Services MSS LLC, and how much the organization see the value in you to come on board and work with us. So this is the message for probably the last session to begin with, as an organization from Module Solutions and Services MSS LLC. And I know guys might have question regarding this. Many of you guys will hear it on the recording, and you will come back with a question. That's perfectly fine. We can discuss if you guys are currently in the session can present their questions regarding this certification or job opportunities with Module Solutions Services MSS LLC. after the session, and we will discuss in detail, and we will find how can we succeed together. So let's jump back to our trading course material for the day. If you guys can recall, I'll give a brief recap of half of the section which we covered for this chapter, which is distributed antenna system design using Ibwave. We covered in the session 5 part of it. In the part which we covered in session 5 was basically we introduce you guys with the what are the functions of Ibwave, what are the components, what does the Ibwave do itself, regarding what are the important uh, features of IBWave, like it does the design plan, floor plan, predictions, and cellular systems. We went through the design system components. We saw what is a splitter in general, what is a four-way splitter, what is antenna, we studied two different kind of antennas, and what are their specifications, what are their gains, and what is omnidirectional antenna, and which band they operate on, and how to read the spec sheet of these antennas and the cable. What is a CCI tray? We explained the CCI tray's interface between Node B and the DAS equipment. We discussed that in the last session. We also discussed design environment and system components. To get acquainted with the Ibwave, on the Ibwave software, we saw the complete details of its components and other in this video, which is which covered design environment for the Ibwave. We saw through some DAS equipment introduction. We saw two different DAS equipments from TE. We discussed that how the DAS equipment is a separate part from the node B, and it is connected usually through uh, through CCI tray, and any DAS equipment is a main hub and RUs, or sometimes main hub and expansion hub as well. This was example for TE. This is the RE for the TE. Then we discuss an example of mobile access. Mobile access usually don't have expansion. It has just the main hub and the remote units. Then we had a panel and utilities video, which was 1B, which we played and saw. Today we will start with the second video of panel and utilities, which will explain you what panels are there, what utilities we can use, and how they are being used in Ibwave. So let's begin today's session with this video now. You guys have to give me information if you guys can hear this video well or not. As soon as this video is played, I'll stop the video for a while and ask you the question if this video is playing well or not. So, do you guys have any questions regarding the last session regarding the DAS design? Because our DAS basically is three major chapters of DAS. One was one was the DAS design without using Ibwave, where we get acquainted with all the concepts and the process and the workflow, and what are the concepts required. Then we are in this chapter, which is a DAS design using Ibwave, where we are getting familiarized with the software. And our third session will be uh, our third chapter will be RFDS preparation. So sorry for that, guys. Skype pops up always. So let's see this video. can you guys just confirm if you can hear the video for this panels and utilities?
This is where all the different output maps can be created. Different floor or output maps available. For example, the first option we have here is the antenna contour. So let's say this is our layout plan. I can enable, for example, the antenna contour for system 1, and it shows you the antenna contour here. I can do that for system 5, for example, and it will show me that in green, just because system 5 is differentiated with a different color, which is green. And we can try that for system 3, and this is what the antenna contour looks like. I'm gonna move forward to talk about some prediction maps. Let me just give you a quick note how you can add a prediction map. You can add a prediction map simply by clicking on this plus button here, and then you can have this window. This is where you can set your configuration type, and whether you want a signal strength map, field strength map, a server map, interpolation signal strength map. Another very popular map is the max achievable data rate map. Once you select your type of configuration, you can pretty much add your map name here, customize it. Let's say signal strength map. You can use the general settings, or you can uncheck this button and you can update the resolutions however you want them to be. So when you are done with your settings here, you simply go to the system tab, and here you have the option to combine system and to actually choose your active propagation model. You have the fast ray tracing, cost empirical 231. The fast ray tracing is set by default, and you have the option to use waveguiding and to use direct path only on the client surfaces while using fast ray tracing. We will go deeper into fast ray tracing later on during this session, and we will explore the different functionalities of fast ray tracing. It is an active propagation model that uses the direct path, diffracted path, and reflected path. The next step here, filters. This is if you want to have your map run everywhere. So let's say I want to run my map on floor 3 or system 2, for example. I will check this box only. If I want the map to run all the systems on the floors, I can select it right here. Color scheme, this is where you can customize your color scheme, and you do that by clicking the edit button, and you can pretty much play with the color scheme. Edit color scheme, you can play with this however you want, update it, apply different colors if you want. Click OK, your map will be created here, and you can view your map simply by enabling that map for a particular system. So let's say we're going to enable the signal strength map for system 2, or for example for system 3. It shows you here the signal strength what you're building. So now let's move to talk about the best server map. So if I enable the best server map here, this map will show you the coverage for each antenna. So if I zoom on this legend here, it will show you that antenna 1 is covering 33% of the area in dark blue, antenna 2 is covering 37% of the area in green, and so on. So if I zoom out here on the floor plan, you will see that this area is covered by antenna 1, this is covered by antenna 2, and this is covered by antenna 3, and so on. So this will show you the coverage for each antenna. And if you do click on the best server map to see the properties, under your specific tab, here you also have the option to combine systems and to consider outdoor signals. So if you consider outdoor signals, here you can consider outdoor signals from a given value, from survey data, or from outdoor prediction. And depending on what you choose, then you're going to have to set some values for a given value, or for survey data means you are importing survey data, and for outdoor predictions means you are not supplying a value, you're just doing outdoor predictions. And below here, of course, you have your active propagation models. You have fast ray tracing and cost empirical 231. Fast ray tracing is always set by default.
Okay guys, so you guys might have the question regarding just the previous slide which was here, this source data, outdoor signals. So what you can do is to import the predictions from eTool or other prediction tools and import it in Ibwave, and then make your predictions based on that how much the outdoor coverage will be stronger. Usually this method is not so effective as Ibwave claims, and usually it's not practically in practice very much used when you are predicting. Rather than importing a prediction from a prediction tool, what we do is do the actual benchmark of the current network. We do a benchmark walk test using TEMS or JDSU, and then we measure our how strong our indoor coverage should be and what is the outdoor coverage is actually there. So that's how we do, rather than importing a prediction from a macro planning tool like eTool or Asset. We actually do the benchmark of our macro coverage reaching indoor or inside the buildings, number one. Number two, the question was, is the 6 dB stronger than the outdoor coverage is a rule of thumb? This is not the rule of thumb. This is usually the practice observed in different operators, and that's the standard, and that makes sense as well, that we should be 6 dB stronger, at least 6 dB stronger than the macro server in order to have dominance of the indoor coverage. Otherwise, indoor will be there, but if it's weaker, it will not able to serve, or it will not able to serve very well. And even if it's serving the quality or the ping pong handover or the ping pallet pollution, will have degrade the performance. So for that purpose, 6 dB rule has found to be effective, and you can say it is a rule of thumb. But it is a very effective rule of thumb, which is being observed in all the major operators. So let's continue with this video.
And for outdoor predictions, means you are not supplying a value, you're just doing outdoor predictions. And below here, of course, you have your active propagation models. You have fast ray tracing and post-empirical filter. You want fast ray tracing is always set by default. Another very interesting map is the max achievable data rate. If we enable that for system 2, this will show you the area on the floor plan where certain throughput is achieved, and you can also improve your design to cover the area affected by interference. Other useful maps we can see later on is the LTE map and the soft handoff maps. Those are available as well. We have covered everything under this panel. Well, I will first move back to our original project. Now that we have covered everything under this panel, I will go ahead and minimize it a little bit and move on to the panel right below that. On the bottom here, you will see we have the systems info panel. This is where you have all your different systems, which will allow you to access different systems information. So if we look, we will see the different systems differentiated by colors here as well. These same colors are displayed on the layout plan to show you which systems the calculations are based on. You will see a new feature that was recently added to the Ibwave Design software, which is what you see here. It is called system labeling. The ability to customize the way you label the system in Ibwave Design. The way it was labeled before is System 1, System 2, System 3. With the large amount of systems and the multiple technologies and multiple sectors, it was hard to know which system was what when you were printing reports and when you were showing legends. So we have added here the ability to the way that you can label the systems, so it is much clearer when you display the application now. You can label your system using the system ID, operator, technology, band, block, sector, system, description, and so on. It is very flexible. You can customize it the way you want. And you can make the customization from the project properties, which we will cover later when we go through the project properties. You would also see the name of the system as part of the legends. So let's say we can bring our legends here. If we maximize the view of our legends, you will see your system is displayed here as part of the legends. And if you actually click on the legend itself, you can go to the other setting tab, and here on this empty button here you can enter in custom text or a system information here, and it will be displayed here as well. So we have covered covered the System Info tab, I will move to the next tab we have is the Plans Info tab. Another one that is extremely important is this tab. We talked earlier about the different tabs on our project file. To manage these tabs, we use the Plans Info tab here. So when we want to manage all the layout plans we have here, we do that simply by using this Plans Info tab here. We can organize the floor plans the exact way they are displayed in real life. This helps the software to calculate the exact vertical cable lengths between the floors. You can also add buildings and assign coordinates to them. We can have these floors like that just like in real life. We can do that by switching their order. By clicking on these up and down buttons, we can assign a floor to a building by simply clicking on the floor, then moving it to wherever we want it to be. And we can also add buildings directly from here, and we can assign coordinates. If you right click here on any building and click on show properties, it will show you the Google Earth coordinates. And we will discuss that later during the session. We will see how we can actually import those coordinates from Google Earth. Another interesting feature that was added recently on this Plans Info tab is the ability to set a street level for your building. For those who are familiar with Ibwave Design, in previous versions, when you had a building with 5 levels, for example, but 3 parking levels underground, when you exported this in Google Earth, it showed all the floors above ground, which did not really make sense. Now you can go under the Plans Info tab, and if you do a right click on the layout plan, you have the option to set ground level. If you click on set ground level, the software will take into consideration that level 3 is your ground level and level 1 and 2 are underground, and it will show you that when you export on Google Earth. We're going to move next to talk about the left side here, which is the parts toolbox. So in the parts toolbox, as you can imagine from the name, this is where you can pretty much get the different parts to design your project. You can click on any one of these components. Let's say, for example, I can click on an antenna, and here you can browse by all the different manufacturers, and you can browse by model, and you have a small description, and we touched on the different properties of each of these components. So let's say, for example, I'm going to pick a generic omnidirectional antenna, and once I click on OK, the antenna is right below my cursor, and I can drop it anywhere I want on the layout. You can also design directly with Design Plan. We will cover that later. Let's say I can click on a splitter. Same thing here, I can browse by manufacturer, and let's say I pick a 2-way splitter. I can drop it anywhere I want on my layout plan. And I can click on cable. I can do the same thing here. If I select the cable, once I put my cursor over the antenna and over this red button here, I can just click and drag anywhere I want and connect it, let's say, to my splitter. Just click here and the connection is made. And you can always arrange your cables however you want them to be. So let's say we do that on the design plan here to show you better. I'm going to zoom in on this area here, this white area. I will go ahead and do the same thing pretty much here. Just pick an antenna. Here you will have the actual antenna placed here. And if we pick a 2-way splitter, and I can drop it here, you will notice that on every component there are, let's see here, there are 2 different kinds of ports, a solid red port and a solid red port with a pin. The pin represents an output, and you can only connect an output to an input. So once we do our cable here, I cannot connect, if I click here and drag, I cannot connect it to this port. I can't connect the output to an output, but I can do that to an input. The software supports copy-paste, so you can pretty much click on any one of the components. You can do copy, and you can paste that component anywhere else you want. And another cool tool that I want to show you here is the clone stamp tool, which you can find here. Once you click on the clone stamp tool and you click on any component, you basically create a clone of that component and you can drop it anywhere. I'm gonna go ahead and delete what I've done here. This was pretty much just showing an example where you can.
So guys, one thing which you guys must observe, I believe repointing it, that there's a floor plans, which is one, in this case one B1 basement, B1 floor 1, B1 floor 2, which is B1 stands for probably the building one. You can see this even on the design plan, it is divided into floors. This is one floor, this is the other floor. This, like, each of them is a floor. So even the design and where the equipment is located is mentioned as a floor. So each of the, if you drop equipment on a given floor on the design plan, then on the floor plan that will start to observe somewhere on the floor plan as well on the respective floor. If you drop an antenna or any other component on the floor plan anywhere, it will start to appear on the design plan. So that's that works together and is one of the important features of Ibwave as well. I hope this, what I tried to explain, is understood. If not, you can question me. I will play the video.
Your different components. I will move to talk about the preferred parts list here. This is some other way of dropping components. You can set your preferred parts list here. If you click here, you can create a new part, and you will take you directly to your parts here. Or you can create a new group. So let's say we can call this group sample. Once we do that, we will see our group here on the bottom. So let's say I want to assign some components to my sample group. So I'm going to click on new part. I can pick any antenna here, click OK. It will be shown here on my sample. You have groups here. We can double click and just drop our part anywhere we want. This is an easy way while you are designing. On any part here under the preferred parts list, you click on the part.
Can you guys hear it now? Tosin, can you hear it now?
You can assign it a shortcut, so you can drop it just by using shortcut. You can use it here. And this is the preferred parts list. Next, we're going to move to talk about the component browser. This is a list of all your available components in the database. You can set a star next to a component. Once you set the star, means you set this component as your favorite, and it would be easy to find it. You can sort by favorites, so you would bring your favorite parts to the top. You can sort by manufacturers, models, and so on. Here, under the search bar, you can search for a particular component. I can type antenna, and he will pull all my antennas here if you want to search for a specific part. As you see, there are many ways to design. Each designer usually finds a way that he is comfortable with. It is simply a preference at this point. When you are designing directly on the layout plan, the difference is that the components are represented by pictograms, and when you go to cable them and run your cursor over them, the component actually appears, and you can still easily make the connection to each of the components. And you can also design your desk directly on the layout plan or on the design plan, as we've seen before. Next, I will move to talk about this utilities box here. So just finishing on the environment. The next one is the utilities. For example, if we click on calculator, this is a very straightforward shortcut, simple shortcut to the Windows calculator. You would put the Windows calculator here for you. Next is the frequency calculator. Once you click on it here, this is what we call a frequency calculator for in-building designers. Depending on the region you are designing in, you can actually choose the region here. Let's say Europe, for example. So once you choose the region, you can choose the band and choose the technology to go with it, and it will give you all the different informations about the uplink and the downlink channel information right here at the bottom. This is a very handy tool for the in-building designers, especially if you are designing in a new band that you are not used to, or if you are ordering some specialized filters, duplexers, and things of that nature. You can have this resource handy inside the tool. The next one is the narrow band 3D order intermont. Click on it here. It is handy because more and more it is becoming very popular to overlay multiple technologies on the same dash system. This is a third order intermod calculator where you can enter all the downlink frequencies. For example, I can enter frequency here. I can enter another H02 frequency here, and probably another H04 frequency here. Once you do that, you have this band separation here where you can enter your band separation, let's say 80, your amplitude, let's say we enter 21, and let's say we do 33 for the IP3. Once you do that, you will see all the intermod products on the right side. You can also launch a quick graph displaying the carriers and where each intermod product falls. So if I click on graph, it will show me here. This allows the in-building designers to evaluate if you still meet your minimum signal to noise, and obviously not here, so you can go back and make changes until you actually meet the requirements. You can also have it in a report format, so if you click on report, it will display the report format here for you. I'm gonna go ahead and close this and move on here to the last part, which is the power converter on this utility toolbox. So this is what we call the power converter. It is a simple converter from watts to dBm and so on. So here you can enter a value and it will give you a result if you want to convert from watts to dBm, milliwatts to dBm, and so on. This is very much a handy tool that can help you do quick calculations. Very well, then the last part of the environment that I want to cover is the debug message list. The software has some intelligence. As you are designing, it checks for compliance. This will display all the warnings and errors in your project, and of course it will give you a quick chance to fix your errors. I will show you a quick example here. Let's say, for example, we have this antenna. This is the frequency for it. I will go ahead and pick another antenna, for example, with a totally different frequency, and let's say we pick this one, which is out of the frequency range. Once we do that, we have errors here, and it pretty much tells you that this antenna is not, the frequency is not supported. So once you click on your error, it takes you directly to the antenna, so you can fix your error. So if we go ahead and pick another antenna that is compatible with the frequency, our error automatically disappears. What's happening very often these days is that people are going back and forth to existing projects to add new technology, add a new frequency band. When you add a new frequency band to the software, it actually highlights for you any components that are not compatible with that frequency or technology. You can go to any of these parts to fix the errors and warnings by clicking on the part, and it will take you directly to the part in question. And you can also click and do select all here. Once you do that, you can export all your errors and display them in a spreadsheet should you want to go through them, or print them and go through your messages one by one and analyze them. This is it for the environment of Ibwave Design. This was a quick overview of the environment you will be designing in. In the next part of the class, what we are going